We're going to look at the conjugate of complex numbers, and we'll go ahead and write out what the formula is for our complex numbers, just because we want to make sure we get that engraved in our minds. So we have z, in this case z is going to be our complex number. We have x, which is going to be a real number. Same thing goes for y. Y is a real number. And then we have I, and I has that special property where I squared will be equal to -1. Now, what exactly would be the conjugate of a complex number, right? So we are clearly going to be acting on the complex number part, which would mean that the conjugate is going to be this. It's going to be z with this little bar on top of it. That will be the way that we will write the complex number, or the conjugate of the complex number, sorry. So go ahead and write that, complex. And down here, I'll write conjugate. Of complex number. So what we're going to write here instead, the conjugate is still going to have that x term, but now you're going to have minus I y. You are essentially going to be switching the sign of y. And we can go ahead and we'll draw this out to make sure that we are all visualizing what's going on here. So in the first video we looked at complex numbers, I showed you that this here would be r, we'd have x over here, we'd have y up here, and we'd have some point out here, which is going to be the point that represents your complex number, right? I plus y, that would be your point z. And we had, I'll just draw some dotted lines over here. We saw that this matched up right over here. So if we were to take the conjugate, right? If this over here was going to be z, then if we're flipping the sign of y, well, we'll just have y minus down here. And that means that somewhere over here, we are going to have x minus I y, which is equal to the conjugate of z. Go ahead, we'll draw some dotted lines right over there. So we see that that's how it's going to change. It's going to change from going up here to going down here. So that is the effect that the conjugate will have. Now, one thing we want to look at is just want to look at some properties of this, if you will. And this is something that if you've seen anything related to set theory, it's going to be really easy and it's not going to be anything complicated. So what we call involution is when, so involution is when we take the conjugate twice. And essentially, you can probably guess what's going to happen. You get twice. Like if you were to multiply something by a negative number 2 times, like say -1 twice, you're going to get back to where you started. So in this case, if we have, so this is the conjugate of z, and we have the conjugate of that, well, we are going to go back and just have z straight up, which means if we had z is equal to x plus I y, and we were to go ahead and take the conjugate, we would have z is equal to x minus I y, and if we were to go ahead and take the conjugate yet again, we would go back to having x plus I y. So that's all I think I will keep for now. I don't want to get too detailed, so that's all we'll look at when it comes to conjugates, right? So we're going to keep it like that, and then we'll keep going with conjugate numbers and some more things involved. Actually, no, let's keep going. Actually, that's a lie. I think I want to fit all the conjugate information into this one video, so we don't need to just drag it on too long. So some more things with conjugates. We're going to go say that r, so real numbers, will be fixed by the conjugate. And this is to say that if z is equal to z with this bar on top of it, then we are going to say then z is a real number. So that means z is part of the realm of real numbers. One more thing to say about conjugates, one thing that we will end off with, is that complex conjugates, and was it understood what I had said before? I just want to make sure. If it's found, I'll go ahead and just say this one more time. If it's found that z is equal to the the conjugate of z, then that means z is not a complex number, right? Because that means that your I is not having any effect there, and they're going to be the exact same thing. So if it's found that they are the exact same term, then you don't have this, right? We saw clearly over here when we're dealing with complex numbers that we're taking the conjugate of, these are clearly not equal to each other. And thus, not real numbers. There we go. I felt like I just didn't give enough explanation to how that was working. So there we go. There you have it. So one last thing we will end off with. So if it is a complex conjugate, so if z is a complex number, then it will satisfy. Sorry, I lost my train of thought. That if we were to have the conjugate of z1 and z2, that would be the same as them being individual. So if we were to multiply z1 by z2, so if you were to multiply them and then take the conjugate, it's going to be the exact same thing as taking the individual conjugates and then multiplying them for complex numbers. And then we will see the way that if they were we were adding them as well, it's going to apply. So if we were adding z1 and z2 and then taking the conjugate, this is the same thing as taking the individual conjugates and then adding them together individually. So it does not matter which way you add them or multiply them with the way when you go to take the conjugate. So I think that's what I'll end off with there. Now we're running on for a bit too long. I guess one last property, why not? And then for real we're done, I promise. So z multiplied by the conjugate of z is going to be a part of the realm of real numbers. So multiplying a complex number by its conjugate will give you a real number. I do have some more things I want to say about conjugates in the next video. Okay, I promise we're ending it off here. We'll look at it in the next video.